Hello, my name is Alicia Rybicki, a PhD researcher in the University of Birmingham. Dopamine plays an important role in the regulation of reward learning, affecting adaptation to environmental volatility. Social learning refers to learning from observation of or interaction with another person rather than through own direct experience. It's unclear whether social learning is underpinned by specific social mechanisms or domain general ones, with similar neurochemical signaling mechanisms underlying learning from one's own outcomes and from observing others. Recently, effects of dopamine manipulation were found on adaptation for individual reward learning only, not on social, suggesting domain-specific mechanisms for social learning. However, in this and most other paradigms, the social learning is an indirect or additional information source secondary to the directly experienced reward information. We thus predicted that if it were the directedness and not the social nature that dopamine affects, we would see effects of dopamine manipulation on the direct source of learning only, regardless of the social nature of the information type. We tested this by perturbing dopamine signaling using haloperidol, a dopamine antagonist, in a double-blind randomized controlled study where subjects completed a reward learning task. Where half did a task where the social information was indirect or inferred, for the other half the direct and indirect nature of the learning types were switched, making the social information into the direct source of learning, with individual information, previously the direct source, comprising the additional or indirect information. We thus had two groups. Behavioural analysis were conducted using win, stay and lose shift scores as a proxy measure of learning, with the difference between volatile and stable trials used as an adaptation to environmental volatility. Results showed that under placebo, for individual information, subjects showed more loose shifting in volatile over stable phases, and more win, staying and stable over volatile. Haloperidol reversed this, leading to more loose shift behaviour for volatile over stable and more win staying for stable over volatile from learning from social information. Importantly, we did not see an interaction with group, implying haloperidol affects learning from each information type in the same way, regardless of the directedness of the learning source. To further investigate effects of haloperidol, we looked at perseveration, or staying with the same option, reflecting a failure to adapt, ignoring rare events in a stable environment and flexibly updating beliefs when our environment is more volatile is optimal during learning. Results revealed that under haloperidol, more staying was observed in volatiles compared to stable phases for individual information, with the opposite pattern observed for social information, regardless of the directedness of the information source or whether or not the choice resulted in a win or a loss. Our original prediction that dopamine antagonism would reduce adaptation to the environment during learning for the direct source of learning only, regardless of the social nature of the information type. Instead, we observed that dopamine manipulation affected win-stay-lose shift response to individual and social information in the same way, regardless of whether they were the direct or indirect learning source. Results are not consistent with the domain general view of learning and force us to consider that there may be domain-specific mechanisms underpinning social and individual learning, at least at a neurochemical level. Further work will involve follow-up with computational modelling of behavioural data. Thank you.